this weekend, you should have received an email from me with your grade. Okay, it should have had your grade for the course, right? Both in the percentage and the letter. All right, and the majority of you guys did really, really well. Okay, the majority of you all did really, really well. And it will probably come as no surprise that I made a graph of how many hours you put in on Apex and your absolute grade. All right, and in general, the more hours you put in on Apex, right, up to a certain point, okay, the better your grades were. Okay, so the people who got like 98s, 99s, those were the people who put in, you know, anywhere from 55 to 75 hours. Okay, if you're putting in more than, you know, 75 hours, please reach out, because that makes me feel like there's something you don't understand. Okay, so you should be putting in somewhere around 55 to 75 hours. That's what the course is asking for. All right, and then those people who put in that amount of work and got those really high grades, thank you for proving my point there. Okay, so that's what we should be averaging here. All right, now I did a little bit of restructuring, right, and based on what we've done last semester, and by last semester I mean the last 4 weeks. Okay, I made a schedule for both Algebra 2 and Pre-Calculus that are hopefully going to make things a little bit easier, not so back-end heavy like we had last time. Okay, but before I get to that, I need to share with you a reminder here about what we are doing, why we are doing it. Okay, so again, the whole point of this is for you to be able to move up to the O'Toole Honors Program, right, in the fall. And the ones I want to really point out here are 4 expectations. Okay, so you've got to have both semesters completed, obviously, right? That's why you're here today. You have to have 100% completion of assignments, right? Again, the assignments that I assign. All right, you must have a grade of 75% or higher, right? And then now you know that the grades are 80% based on Apex and 20% based on your attendance and participation. All right, and then no more than 2 unexcused absences, right? You can have 2. On the third one, we're getting into some water here. All right, so again, meeting times here, same as last semester. We're gonna keep that structure. All right, we will have the same class structure. Okay, we're gonna have 3 weeks of meetings. All right, 3 weeks of meetings, and then that 4th week is your solo week. Okay, and again, I'm making a schedule that I'll share with you in a second. All right, I'm making a schedule that has us completing all of our work within the 3 weeks, right? So then that 4th week, all you have to do, if anything, is take your final. All right, but for those of you who maybe caught or fell behind a little bit, right, you know that 4th week is your time to make up a lot of things. Okay, so please, again, remember that that's our structure. Okay, Zoom etiquette, again, same thing. All right, I need your cameras to be on. Obviously, I need some portion of your beautiful, lovely face, right? Again, I don't even care if it's just your forehead. All right, I just need to know that you're here, you're willing, you're ready, and you're rocking. All right. And then that's about it here. Okay, that's about it in terms of this welcome presentation that we started with last time. Okay, it's the same basic principles here. All right, now the only difference that I know that is coming up here, so if you're a person who does activities or sports, make sure you perk your ears up here. All right, I know that restrictions on sports and activities and gatherings are lightening up here. All right, in the next couple of weeks, or at least I'm hoping, right? Fingers crossed, right? So I know that you might have a sports camp or a drama camp or, you know, something along those lines. All right. If it is a St. Lawrence sponsored activity, camp, event, whatever, right? If it is a St. Lawrence sponsored event, right? So let's say you have softball camp next week and you might have to miss 30 minutes of our class, right? Okay, whatever it is, as long as it is a St. Lawrence sponsored event, okay, I have four new guidelines here. Okay, I have 4 guidelines that I will share with you. Fiddle Zoom. Guess not. All right. I have 4 new guidelines here that I will talk to you about, right, in order to make sure that you're not having to choose between program movement and your involvement in your sports. Okay. So I'm going to share this with you. All right. And then obviously we'll go through there. All right. So if you know you're going to miss a day, all right, and you can't miss every single day, let me throw that out there, okay? But if you know you're going to miss maybe the last 30 minutes of a couple days, or you're going to miss one whole day completely, right, for a St. Lawrence sponsored event, what you're going to have to do is similar to if you would miss normally, right? You're going to have to email me the day before you're going to miss class, right? If you're going to be missing the entire week for whatever reason, you can email me at the start of the week, okay? So if you have a softball camp where, again, you're going to miss the last 30 minutes of every day, just email me and let me know that, okay? You've got to include the days or times that you're going to be missing, the athletic event or you know, the activities event, right? So I guess I should have just put event there, right? But the event that you're going to be missing, and the STL coach, let's go with teacher or trainer in charge, okay? So you've got to tell me who's the STL coach, teacher, or trainer in charge, okay? Because what I'm going to do is if I don't know, if Dante says he's going to go to baseball, right, and he says that Coach Pete's in charge of that, I'm going to go and check with Coach Pete to make sure that Dante's butt is actually at baseball. Otherwise, you're just skipping out on both things, okay? So, again, I'm going to periodically check with those people to make sure that you're there and that your absence is real, right? To me, it's the same thing as like when you get a note from your doctor and you have to bring that note into school, right? It's validation that you actually went to the doctor, all right? Because what I'm going to be doing is similar to what we ended with. I'm going to record the daily lectures, but instead what I'm going to do is I'll post them as an assignment for whoever missed. All right, and I have a special way of doing that on Google Classroom, so no worries, you're not going to see anything if it doesn't pertain to you. All right, but again, if Maddie has to miss a day, all right, if Maddie has to miss a day for whatever reason, right, I'll post an assignment that day for Maddie, and what it's going to be is it's going to be an ed puzzle, right? So I'm going to take the lecture that we have for class, and I'm going to make it an ed puzzle, all right? And what you're going to be asked to do is watch any ed puzzle that you missed by the start of the next week, okay? So by Sunday at midnight, you need to watch whatever ed puzzle it is that you might have missed for that week. Okay, otherwise it's going to count as an unexcused absence. All right, and for those of you who maybe aren't super familiar with Edpuzzle or whatever, all right, I'll give you a prequel. On Edpuzzle, I can see how long you watched it for. I can see exactly where you stopped. I can see the last time you tried to get on it. All right, so there's no ifs, ands, or buts about it. If you don't watch that video fully, right, so if it's an hour and a half, you need to watch the entire hour and a half and be on it for at least that long. Right? You need to make sure you're watching that full video, and then it'll count as an excused absence, right? If it's not watched, it's going to be an unexcused absence, all right? So you got to make sure that you're following up with that, all right? And then obviously, if you have any questions on the materials, you'll reach out to me, the Apex teacher, or the online tutors for the day that you missed. And then you are still responsible for completing all work assigned on Apex, maintaining that 75% or better, and then again, no more than 2 unexcused absences, okay? So again, that's the slight change here, all right? And again, no, you cannot miss every single day, right? If that becomes a problem, then we'll have to chit chat about that privately, all right? But again, this is my way of trying to make sure that we can accommodate all of those things that I know you want to do, with everything kind of lightening up here, hopefully in the next week or 2. All right. So again, if you think that might pertain to you, then you can either stay on after this class, or you can, again, always email me ahead of schedule, and I'll remind you what needs to happen. All right. Again, this is our slight change here. right? But regardless, I'm still gonna post the videos for class every day on YouTube, right? And then it dumps that onto Google Classroom for everybody, right? So you'll still have access to that. All right. So then for Algebra 2 here, okay, for Algebra 2, what happens with Algebra 2 is we have 5 units, okay, we have 5 units, all right, and it ends up being about, including the test, we have about 10 sections per unit, okay, we have about 10 sections per unit, all right, which means we need to do, if I'm calling this a 5-day work week, right, 4 days on Zoom, and then we count the weekend as just one big day, right? If we count that as a 5-day work week, then you need to, or we need to cover about 3.5 classes a day, all right? So about 3.5 classes a day in order to not have any work over the next, over that 4th solo week, okay? So if you can see this, awesome. If not, don't worry, I'll post it on Google Classroom, okay? But again, I have split it up by units, right? So we've got, again, our 5 units and then our exam, and then the dates that we're going to be working on them. So like today, I'm going to have these 3, right? And I know I'm taking time for this intro, so if we don't get to the 3rd one, right, then I'll post that as a screen recorded video for you, and then you can watch that and still complete that, right? So again, every day we're going to cover about 3 units, okay? We're going to cover about 3 to maybe 4 units, all right? And again, a unit does include a test, right? So on this testing unit, it may not be a lot of work, but on the upfront, but you'll have that bigger test there, okay? And we are going to keep the same rule that we developed throughout the course, all right? Any practices or journals, right? Any practices, journals, or I think there's one project. Nope, I guess not. All right, any practices or journals are going to be extra credit, okay? Any practices or journals are going to be extra credit. There's one I missed. All right. So those will be extra credit, and then we are only taking the CSTs. We're not going to take the TSTs, okay? So hopefully, again, it's a little bit lighter of a load for you. We're only going to take the CSTs and not the TSTs, all right? So again, we're going to end with this similar structure that we started with at the end of first semester there. Okay, we're going to have the same structure there. So practices and journals are extra credit, and then we are only taking the CSTs and not the TSTs. All right. Okay, so before I keep going, does anyone have any questions, anything they want addressed, anything they have from what we started? Anything? Okay. Awesome. All right, so then this morning at like 5:09 a.m., at like 5:09 a.m., everybody should have gotten a welcome to semester 2 of Algebra 2 message. This time we have a different teacher, okay? We have a different teacher. It's it looks like Danielle Sanders, okay? So we have a different teacher there, all right? But as you noticed here, the student guided tour video, okay, that's still extra credit, all right? So she posted that. It says optional, send me an audio video that includes your first name, last name, extra credit, right? So by all means do that, because that's extra credit that I also give you, all right? So you should have access to Apex Semester 2, and from my understanding, it should just be the exact same everything information, and when you log in, you should be able to see both semesters. Since I'm looking at her, Miss Maddie, can you log into Apex and double check that for me? Do you have both semesters there? Beautiful. All right, so you should have both semesters there. All right, so then, again, we have 5 units. Okay, so we're going through rational expressions and functions, radical expressions and functions, exponential and logarithmic functions, statistical analysis, and then we're going to start something called trigonometry. Right? We're going to introduce trigonometry here. All right. For my juniors, I know a lot of these look familiar. Okay, so that should be a positive thing for you. For my sophomores, don't worry about it. We're going to get more familiar with it. All right. So for unit 1, we're going to deal with rational expressions and functions. So if we look at this overview here, all right, we can watch this video here together.
Pineapples make great snacks, but have you ever seen a pineapple plant? They start out as little blossoms in a tropical field before traveling across the world to your supermarket. When you cut a pineapple in half, it's pretty obvious how many pieces you have. But if you're having friends over for a cookout later, the pieces can get smaller and harder to keep track of. Basically, you've got a division problem. Have you ever seen an animal that seemed to be made of different animals? You might say that you're about to meet the platypus of algebra, rational functions. And once you get over the unusual arrangement of the pieces, you'll start to recognize more than a few familiar features. You'll see that rational functions can sometimes resemble inverse relationships. Rational functions can be graphed, and their graphs may have vertical asymptotes. To graph across the asymptote, it all begins with your old mathematical tools, arithmetic. In this unit, you'll see that you can add, subtract, multiply, and divide, not just counting numbers, but variables and variable expressions as well.
Okay, so again, that's a quick introduction to this thing called rational expressions and functions. And the big thing that they pointed out there that they did, I think, a pretty good job of was showing you that it's similar to what you already know. Okay, so it's similar to what you already know. It's just going to get a little bit, I'm going to say, not as nice here, right? It's not going to look as clean, but once we kind of dig through it together, we'll find out that, hey, we already know how to do this stuff. It's just taking on a slightly different form here. All right, so if we start with this thing called proportions, okay, proportions. It's talking about how you can change things without actually knowing the size, right? So I'm assured everybody's gone to print a picture, hopefully at some point. Maybe I'm just really old here. I had to go to like Walgreens or something to print my pictures, okay? But starting off with a picture, right? So maybe you printed it and you wanted a small version, right? So a small version, maybe a 2x3, so like a wallet size. All right, so you might go something, I know this isn't 2x3, this is larger, but maybe you start off with something that's Post-it note size, right? And then you want to scale up to maybe something that fits in a picture frame. Maybe then you want something that's even a larger picture frame, right? So all of that stuff, okay? So that's talking about this thing called proportions, right? And knowing how little or how large something is compared to something else, right? Or scaling up or down. All right, so when we start looking at proportions here, all right, they're talking about if you want to make a recipe. Okay, so if you're looking at a recipe here, how do I scale up or down to make more or less from this standard recipe that I have? Okay, so if that was my original ingredients here, sorry. Okay, so the brownie recipe called for 2 cups of flour, but we only have 1.5 cups. Okay, so what could we possibly do, right? Well, yes, okay, great. We could not bake the brownies, duh. All right, we could go to the store, buy more flour. We could use the 1.5 cups of flour to figure out how to change the other measurements, and we technically could replace the flour with a different ingredient, right? But assuming that we really, really need these brownies as soon as possible, we can use just the 1.5 cups, and we can do this thing called scale down, right? We can scale down everything to kind of match that 1.5 cups of flour that we had instead of 2, right? So in order to do that, there's this thing called a rational expression, okay? A rational expression. It has the form A over B, where A and B are polynomials, right? Are polynomials. All of the bottom are examples of rational expressions, okay? All of the bottom are examples of rational expressions, okay? Again, they have to have at least one variable in it. They have to have at least one variable. And, sorry. And obviously they're in that fraction form, okay? If we keep looking at this though, we can find out that rational expressions can be used to find the thing called proportion, or as another way of saying it is a ratio, right? A ratio. And a ratio, if you don't know what it is, it's comprised of two values and can be expressed as a fraction, right? So you might say 1 to 2, right? That's a ratio. Or you might just say 1 over 2, which is 1/2, right? You might say 1 over 2, which is 1/2. All right. And it can be, like I said, it can be expressed as a fraction. So for example, if Hugh High School has 2,400 students and 160 teachers, what's the student to teacher ratio, right? So you would just do students over teachers, because what it says is it's student to teacher. If it was teacher to student, you would put teacher on top. All right, but it says student to teacher. So you go student over teacher. You fill in the values, 2,400 over 160, and then if we can simplify or reduce, we do. Right, so there's 15 students for every one teacher, or we could say 15 over 1, right? So those are the two ways that you can write a ratio there. 15 over 1, or 15 with those two dots, right? That colon, 1. 15 to 1 is how we would say that. All right. So then looking at two equal ratios, okay, since they're expressed as fractions, again, we can reduce them the way that we do fractions, right? So for example, 360 over 24, right? So since those both could be divided by 24, we can reduce that again to 15 over 1, all right? And again, regardless of if it being a really large number to start with or a really small number, what we found out is that the ratio is the same here. Okay, the ratio was the same. So these things are proportional. Okay, they're equal. So you could write them as this thing called a proportion. All right. So what we show that is, I know it's kind of hard because it's really small. Okay, 2,400 over 160 is equal to 360 over 24, all right? And the reason we can write it like that is because they both reduce down to 15 over 1, which is equal to 15 over 1, right? These two ways are the same way of saying 15 over 1, okay? So since they're equal, you can write them as a proportion, all right? They're equal to each other, all right? And this becomes super important because if we don't know a value, right, but we know that they are equal to each other, we can solve for that, right? We can solve for that. And one of the most important things we're going to have to learn is this thing called the cross product, okay, the cross product. And the reason it's called cross is because you're going to multiply diagonally, right? You're going to multiply diagonally to find the cross product. Okay, so if we look in general here, if I have A over B is equal to C over D, we know eventually they're going to equal the same thing on the left and the right side. But if I can do this cross product thing, I'm saying A multiplied by D is going to be equal to C times by B, or B times by C, all right? So this is what's called our cross product. Okay, and we can do this when things like this here, they don't look as obvious. They don't look as obvious. But if I multiply 2,400 by 8, that should equal 120 times 160. When I carry those out, those give me the same number. All right, so this is our cross product rule. All right, and yes, if you're thinking it, technically we could reduce both of these down, right? We could reduce both of these down to a simpler value, right? 2400 over 160 could get simplified down to 120 over 8, or even further than that, right? If we divide 120 by 8, okay? But this is going to become very, very helpful, because if I don't know what this top value is, I can then use my cross product here. I can use my cross product property to solve for it, okay? So what that looks like here is, again, if I have 3 over 8, and I know that it's got to be the same thing as x over 20, right? Because I told you they're equal. I can use my cross product property to solve for x. So I have 8 times by x, right? I do this cross product, okay? Another thing people have said it, again, I might be just super old. They've also called it like butterfly technique, because you're crossing it and you make it kind of look like a butterfly. If I can, like, again, I don't know what butterfly looks like that, but that's what I was told when I was growing up, right? So that cross product rule, or, you know, whatever else you want to call it. But it looks kind of like that, right? So again, you multiply the crosses, and so now we should have 8x is going to be equal to 60, right? 8x is equal to 60 if this is a true proportion, right? So then we can take and divide by 8 to get x by itself. So we know that x is going to be equal to 7.5, right? So this ratio of 3 to 8 is also equal to 7.5 over 20, okay? Is equal to 7.5 over 20. Because when we reduce them down, they're going to give us the same value, all right? And let me get my calculator here so I can give you that number. All right, but 3 divided by 8, again, you can always check yourself. 3 divided by 8 gives us 0.375, all right? And 7.5 divided by 20 gives us the same value, that 0.375, all right? So all I did was I plugged my x value back in up here, and then I simplified, and I just made sure that my left side equals my right side, okay? Now when we go to here, okay, it might be a little bit more involved, because now we have a binomial, we have a binomial, okay? But it's the same process here, okay? You're going to do the cross product. So 1 gets multiplied by both of these values here, 7 times 11. Okay, we multiply out, or we would have distributed that 1, all right? Then we're going to subtract 3 to the other side, right? Again, we're trying to get x by itself. Then we have 80 equals 2x. We divide by 2. X is going to be equal to 40. All right, x is equal to 40. All right, and again, simply to check yourself, you can plug 40 back in here to x. So we would do 2 times 40 minus 3, and then you would put that underneath 7. So 7 divided by whatever your answer is should be the same thing as 1 over 11, right? And I'll give you the hint. It's 7 over 77, okay? So again, you can always check yourself here to make sure that you're correct, all right? And how we can do this is, like I told you, resizing images, okay? Resizing images. So they started with an original 9 by 11, all right? But I want to make that and have a width of only 8 inches, okay? So then the question becomes is, what is my height? All right, what is my height here? Okay, we can do our cross product, right? We could do our cross product to figure out how tall this painting is going to be, all right? So, again, when we look at the picture here, we can distort it horizontally, vertically, or no distortion, okay? And distortion just means changing the shape, basically. All right, so again, it's important to keep a ratio. It's important to keep a ratio because if I only took it and only kept the height the same, but I wanted to change the width, I end up with something that looks like this. If I wanted to keep the width the same but change the height, Again, I'm changing what the picture looks like. All right, only when you use a proportion or a ratio, right, can you perfectly scale down the photo without changing the features of it. Okay. So this one here, again, width is the same, but height is twice as high as the width, right? For this one, maybe the width is 7/6, and for this one, it's 3/4. All right, it's 3/4. And if we look at the original here, okay, the original is also 3/4. So again, if you have the same ratio of width over height, okay, if you keep that ratio the same, you end up scaling down or making the picture smaller or larger without changing the features of the actual picture itself. Okay, so if we look at this here, we rewrite it. Okay, if we rewrite it, width over height is equal to 3/4. Okay, so another thing we could do is we could multiply both sides by height. Okay, if we multiply both sides by height, you can see it gets rid of the height on the left side because it's on the bottom. So what another way of saying this is width is equal to 3/4 times by our height. So our width is equal to 3/4 times by our height. Okay, and hopefully we can see that. We multiply both sides by height. Height would cancel out here, and then we get 3/4 times by our height. All right, so then here, if we look back at our original problem, we have 9/12 is equal to 8/8, right? We're trying to figure out what is our height here, okay? And now that we know, we can plug in 9/12 is equal to 8/h, right? 8/h. Okay, again, you just plug in the values that you know. All right, and since we're looking for this denominator here, what we're going to have to do is we'll have to multiply by h. Okay, so look, hopefully you can see that, right? They did a couple steps here. You've got 12 and 8, okay? They multiply 12 and 8 over h. 12 and 8 over h. That gives me 9 on the left-hand side. Then I multiply by my h. Okay, so effectively, all they did here was they did the cross product rule. Okay, we did the cross product rule. They just split it into 2 steps. Okay, so step 1 here, they did the cross product rule for my 12 and my 8. Okay, so 96 over h. Now we do the other side of the cross product, 9 and h. Okay, so I'm left with 9h equals 96. Then I just divide both sides by 9 to get h by itself. I simplify. So my height is equal to 10 and 2/3 inches. Okay, 10 and 2/3. And something I want to point out here, again, if you're dealing with real world problems, okay, if we're dealing with real world problems, or if we're dealing with real world problems, or if you're given a unit to start with, right? They told us this is 9 inches and 8 inches, okay? First off, you have to make sure that those are the same unit, okay? You have to make sure that those are the same unit. But then when we got to our final answer here, okay, when we got to our final answer, you need to make sure you write inches as well, okay? So again, that's just a real world problem here. Because again, what might happen is if we were actually doing this in the real world, if you just told me, yeah, the height's gonna be 10 and 2/3, I might go 10 and 2/3 what? Is it a centimeter? Is it an inch? Is it a foot? Right? You gotta be specific, especially when we're dealing with real world examples. Okay, so looking here, making a frame. All right, this one you guys should be able to do because it's just click and submit. All right, so I'll leave you guys to practice these on your own here, if you would like here. all right? But again, it's just dissecting the problem. So if perimeter is equal to 2 of the heights plus 2 of the widths, all right? It's asking you to fill in. If it's a 9 by 11, right, you've got 2 9s and 2 11s. You just add them all together, okay? So you guys can try that one on your own there just to check that you understand what's going on. All right, now here with this shadow problem, okay? So you can use proportions and this thing called rational expressions again, right? So if this person is 1.6 meters tall and her shadow at 2 p.m. is 2.3 meters long, how tall is the tree next to her if the shadow is 4.1 meters long, okay? And again, I know this seems maybe a thing that you might not ever encounter, but still it's nice to know and be able to calculate. Again, this is a really nice real world problem here, because maybe in the real world, if this comes up, maybe you have to figure out how tall of a ladder you might need in order to trim the top of the tree, or if there's an apple at the top and you know you can only climb a tree that's 10 feet tall. If that tree is more than 10 feet, we're gonna have to get some kind of, I don't know, apparatus, right? There's a lot of reasons we might need this, okay? So using that now, okay, if we know that this person is 1.6 and their shadow's this, right? The tree has a shadow of 4.1 and we are trying to figure out how tall it is, right? We just assigned it a value of X, okay? We can again set up a proportion knowing that this is gonna be the same, okay? We can set up a proportion knowing that the ratio between them is going to be the same, meaning this person's height over their shadow should be the same ratio as the tree's height to its shadow, okay? Should be the same ratio if you're looking at the exact same time, okay? So what we can do is we can then substitute in the values that we have, right? And again, this is a really, really good process for how to solve word problems, okay? Draw a picture of what the heck it's asking you, all right? Draw a picture, okay? Then fill in what you know in general, right? Tree's height over its shadow should be equal to this person's height over their shadow, all right? Then you plug in the values that you have, right? So I have X for my tree's height, its shadow was 4.1, the person's height was 1.6, and their shadow was 2.3, all right? So then when we multiply this together here, okay, what it's saying is, again, do your cross product, all right? Except for, if I back up here, this time when I do my cross product, I only have to do this one side, because when I do 4.1 times by this fraction here, I get X by itself, all right? So 4.1 times 1.6 ends up with 6.56, all right? And again, X is by itself, so simply here, now I just need to divide, and I'm left with 2.85. All right? And again, all I have to do to check to make sure that this is true, plug my value back in for my tree's height. So 2.85 divided by 4.1 ends up with this ratio of like 0.7, okay? And it really doesn't matter what the answer here is, as long as when I take this person's height and divide by their shadow, it's the same value, okay? And it is. So since those are the same, we did our math right, we have our proportion, okay? Now, back to a baking problem here, okay? This is one of the most common ones where you'll have to use proportions and scales up and down. Is if this person, Mike, is making rice, okay? And you know that you need, for every cup of uncooked rice, you need to add 1.75 cups of water, okay? So he ends up having 3.5 cups of uncooked rice. So to figure out how much he needs, we make a proportion, right? So again, 1 cup of rice per 1.75 cups of water. So I have this much rice. How much water do I need? Right, so those are equal ratios, okay? We want them to be equal ratios so we can set them equal to each other. Now here, again, when we get rid of the units there, okay, we can do our cross product principle, okay, or cross product property. All right, so 1 times by x gives me just x. 3.5 times 1.75 gives me this 6.125. All right, or 6 1/8. All right, and again here, when you write your final answer, 6 1/8 what? Right, we go back up to our original problem here. We're looking for cups of water. The answer is 6 1/8 or 6.125 cups of water. Right, you don't always have to go to 1/8 if you don't want to. All right. But again, remember, if you have this value 6.125, you can go and type into your calculator. If you hit that math button, right, there's that math, and then you can hit the where it has that little arrow and it says FRAC, right? That means fraction. You can put that into a fraction. All right. So again, here, original problem here, we had, we needed 2 cups of flour and we only had 1.5 cups, all right? So with something more involved, if we have a lot of ingredients here, all we do is we set up a proportion, but we do that with everything, okay? And the way they showed it as a generic is, hey, my original is here, and I put my original over my new. Right? You could also show it the other way, new over original. Whatever it is, as long as you're consistent, that's all that matters. Okay? So we started with 2 cups of flour. All right? That's what the recipe called for, but we only have 1.5 cups. And if we're not going to go to the store or substitute or just we really, really want brownies, okay, we're going to scale everything down. Okay? So what this turns into is we have 1 over x, so x is 0.75 if we were to solve for it, okay? So what'll happen is I'll multiply everything here by this ratio, so 0.75, all right? I'll multiply everything by that ratio there, okay? So then here, you've seen that rational expressions are used as proportions, okay? And again, there's those couple problems that we left for you to work on, so you guys can definitely go back and do that. But in rational expressions, both the numerator and the denominator are polynomials. All right, they're gotta be polynomials. Doesn't mean you have to have multiple values there, but they have to be a polynomial. All right. What's a Oh, that took me somewhere else. What is a rational expression? It's where it's in the form a over b, where a and b are both polynomials. All right. What is a proportion? All right. A proportion is where 2 things are equal to each other. And the way that we can check that it's true is if we multiply the cross product and that they're equal. Okay, so if A times by D is equal to C times by B, then we know that it is a proportion. Or if they both simplify down to the same fraction, right? 1 over 2 is equal to 1 over 2, right? But a simple way of doing that is that cross product rule. All right, so again, another practice that you guys can try on your own to make sure that you understand what's going on. All right, but again, you start off simple, making sure that you can do that cross product rule. So 5 over 6 is equal to x over 48. Again, we're trying to get x by itself, so you just multiply this cross product. So 5 times by 48, and then we simplify, okay? So if we do a couple of problems here, 4 over x is equal to 1 over 2, okay? 4 over x is equal to 1 over 2. What I'm going to do is I'm going to have 4 is equal to, sorry, I'm going to have to draw it. All right, so I'm going to do my cross product. So I've got 4 times by 2 is equal to 1 times by x. Okay, so 8 is equal to X. All right, so that one wasn't hopefully too difficult there. Okay, 8 should be equal to X. All right, then if we go down to the next one here, all right, it's the same thing except for when I do that first step here, when I do my 6 times by 8.5, okay, I have X all by itself. So I have 51 on top divided by 3. All right, so 51 divided by 3 ends up giving me this 17 value. Okay. Again, this one here, we do our cross product. So 10 times by X is equal to 5 times by 6. So just doing the butterfly there. All right, and I'll let you try that one on your own. Now, for this one here, maybe it might be a little bit more difficult. It says solve using proportions. A model car is to be an exact replica of the original, but at 1/12 the size, or 1/12 of the size, okay? So if the actual car is 240 centimeters long, how many centimeters should the model be? Okay, how many centimeters should the model be? Well, it needs to be at 1/12 the size. It needs to be at 1/12 of the size, right? So what we can do is we can write this. Oh, there it goes. All right, we can write this as a proportion, okay? So if we know that the ratio needs to be 1/12, right? That means it needs to be new over old. Or another way of saying that is X over, sorry, that's supposed to be 240 centimeters. All right. So when we end up doing our cross product and we solve, we have 240 divided by 12, which gives us a value of 20 centimeters. All right. So the car needs to be 20 centimeters long. All right. And the only other thing I can say on this problem here is the reason I knew it was new over old is because it says it needs to be 1/12, 1/12 of the size. Okay. So think about it in just general terms here. If I told you you're going to have 1/12 of the money you started with, okay, you know that that means you're going to lose money. Versus if I told you you're going to have 12 times the amount of money, you know that it would be a larger amount there. Okay. So then recapping here quickly. Okay, recapping quickly for you. All right. A ratio is two numbers written as a fraction, okay? Where A and B are both real numbers, or sorry, where A and B are both polynomials. A rational expression, though, is where we have two polynomials written as a fraction, okay? So if we have numbers as this fraction here, that's called our ratio. When it is polynomials, right, we call it a rational expression, all right? And whether it's a ratio or a rational expression, we can use our cross product when they are proportions to solve for anything that is missing or to check to make sure that they are equal to each other, all right? So again, the cross product property, those will be equal to each other, so you should be able to multiply those together and get the same answer. All right. So again, when we are doing this, the steps to solving pretty much all of these proportions are to cross multiply, right? Both sides if necessary. Cross multiply, solve for the variable, and simplify, right? Get that variable by itself using all of those properties that we've been working with all of first semester. Okay. So then again here, again, being careful with just the wording. So when we were looking at the picture problem, okay, it was the width of the original over the height of the original. So we had to make sure that when we were looking at our reduced version, we still put that as width over height, okay? So again, use words first, fill in the numbers you know, use the variables for what you don't know. And then again, follow the steps, cross multiply, solve, and simplify. And then again, write the answer in a complete sentence using units from the problem, okay? So being really, really careful that you have units if they give you units, especially on those multiple choices. Like if there's something that says 10 or it says 10 inches, make sure you click on 10 inches if it was in inches, right? And then the same thing for the recipe problem here, okay? Knowing that you have how much in the original and then in the reduced, okay? All right, so for the checkup here, I know we're running a little bit behind, so I don't want to spend too long here. I just want to highlight a couple things. Again, all of these problems follow the same 3 steps here, okay? Cross multiply, simplify, or sorry, get the variable by itself and then simplify, okay? With these word problems here, okay, again, with these word problems, what I do is I pull out the important information or highlight the important information. So as I'm going through this, I would literally highlight 13 hours, earned $91, okay? Then it's saying if he continues to pay at the same hourly rate, right? So again, it's a proportion. How many hours does he have to work to earn $133, okay? So again, highlighting what's important and then figuring out how to write that, okay? And they show you the bare minimum steps, but you know, obviously back in the notes, what they would have done for this exact problem is they would have written something where it would have said like hours last week over pay, and then hours over pay, right? Again, take as many steps as you need with these guys, okay? So that's 1.1 here on proportion. So yes, you do have to take this quiz. And then it looks like we're going to be able to get through it. Hopefully this, maybe start the last one. But rational expressions, okay? So we introduced a little bit with the proportions here, okay? But now we're going to deal with ratios we're going to be dealing with things that aren't as easily expressed, right? So those square root values, okay? Something that is, again, not rational, okay? Something that's not rational, right? So again, to be rational and real, it's got to be a whole number, right? It's got to be a positive integer, all of that stuff, okay? So again, reminding ourselves, rational expressions look like fractions, but they have variables, okay? And it's saying, how would you find the value of this rational expression when x equals 3? When x equals 3, okay? Well, obviously, we know that we would just plug in 3 for those values. Okay, we would plug in 3 for x and then solve, right? And there are different parts of a rational expression, okay? Again, knowing terminology is going to be very, very key here, all right? So this whole top thing is the numerator, okay? As you can see, I don't want to move my mouse here, but as you can see, the top part is the numerator, all right? And the bottom part is the denominator, all right? This entire bottom part is the denominator, all right? And as we're used to in this bottom one here, okay, we know that this is a trinomial, right? And we've got 3 terms, 4x, 6y, and 10, all right? We've got 3 terms, 10 is our constant, 6 and 4 are coefficients, and then x and y are variables, all right? Then up here, okay, we've got that x squared, y squared, okay? X squared is a factor of it, and so is y squared, right? We've got two factors there, all right? So when we evaluate the expression, again, all we would do for that first example is we would just plug in 3 and solve downwards, okay? So would hopefully not too terribly difficult, just plugging in and making sure that we're consistent with how we are applying our mathematical principles, okay? Then we have this thing equal to 0, okay? So again, we've done a lot of this when we were solving for polynomials, okay? But when we're just looking at expressions here, okay? Sorry, a fraction is 0 when the numerator is 0, okay? A fraction is 0 when the numerator is 0. That means when the top is 0. Okay, when the top is 0. All right, and the reason that is because 0 divided by anything is going to be 0. All right, but if the bottom number is 0, okay, if the bottom number is 0, when we're doing this, you cannot mathematically divide by 0, right? Your calculator will tell you error, right? So it has to be when the top value is equal to 0. All right, and obviously we know here that it's going to be positive 1 because 1 minus 1 will give us 0, right? So looking at it, we would make the top equal to 0, so x minus 1 equals 0. We could solve x equals 1, all right? So this rational expression is equal to 0 when x equals 1. All right, now if we look at the denominator, okay, looking at the denominator, like I just said, if we have the bottom equal to 0, it's this thing called undefined, right? Your error might tell you UNDEF, which means undefined, or it might just say error, all right? But if I plug in 5 here, okay, if I plug in 5, it doesn't matter what happens with the rest of these. 5 minus 5 gives me 0, okay? This would be 6, so 6 times by 0 is still 0. All right, and then 4 divided by 0, we can't do it. So this expression is this thing called undefined. It's this thing called undefined. All right, you cannot have the denominator equal to 0 and mathematically calculate it. All right, what other value would give us this undefined? Obviously, that would be when x is equal to -1, because now this guy becomes 0. All right. And again, if you need more practice with that, just setting both of those factors, setting both of those factors equal to 0, right, and then solving. Okay. But what this is saying here is sometimes you need to take an extra step before you can find the value of x. That would make the expression undefined, right? So for example, here we have 5 over x cubed minus x. I don't know about you. I don't know a value off the top of my head that might give us 0 here if I plug it in for x. Okay. So what I might have to do is I might have to factor, right? So again, hopefully nothing new. We've done this a whole lot, just it's in a slightly different form here. Okay, so for this one here, we can factor out an x. So I've got x and I've got x minus 1. All right, or sorry, x squared minus 1. All right, knowing that, I can then factor it again. So I have x, and then it's multiplied by x plus 1 and x minus 1. So I have 3 factors for this, x, x plus 1, and x minus 1. And by interpret, what it means is set all of those factors now equal to 0. All right, so if x is equal to 0, it's undefined. If x plus 1 is equal to 0, it's undefined, and x minus 1 is equal to 0. So if x is equal to 0, -1, or +1, this expression is this thing called undefined. All right, it's called undefined. All right, so this thing saying it can be complicated, right? This slide here is saying it can be complicated. All right, so if you look at this here, they've got a road trip, okay? They've got a road trip, and they've started off with all of these things here. Okay, they know what they're, they know what they're looking for. Okay, they've got their distance from Cincinnati, they know the hotels, and they know the number of people. Okay, so what they're saying is they're trying to figure out where they're going on a road trip. So what's the cost per person? Okay, what's the cost per person? Knowing that you've got the average cost, stay of a hotel, gas mileage, right? It gets really, really complicated. pretty quickly here. All right, but what we can do here is look at in general. Just look at in general, okay? So if I look at the number of miles, right? All of these are starting with miles, okay? Miles divided by the average gas mileage, right? That would give me, if I just look at that, that's going to tell me how many gallons of gas I need, right? So the first thing we're going to look for here is miles times by mileage. Okay, miles times by mileage. All right. Or sorry, divided by mileage. Okay, so the first answer is fine, second answer is fine, and third answer is fine. All right. And then we're going to multiply that by our average cost of gas. So $3.49 a gallon. $3.49 a gallon. All right. Then what we're going to do is we're looking at staying at a hotel for 4 nights. Okay, so we need to add on the cost of the hotel for 4 nights. For 4 nights. Okay, so 4 times the hotel. 4 times the hotel, because it's 4 nights. So whatever cost the hotel is, it's times 4. All right. And then we're going to divide by the number of people. Divide by the number of people. Now, the only difference might be here between these is figuring out how many people can stay per room. How many people can stay per room, right? So for example here, if only 2 people can stay in a room and we've got 4 people, we know we need 2 hotel rooms, right? If we have 2 people, right, per room, and we know we have 4 people, we're going to need 2 hotel rooms. So you might multiply it by 2 hotel rooms. All right. Or if we're taking 2 cars, right? If we're taking 2 cars, we might have 2 times by the factor for the car, right? 2 times by the factor of the car. All right. And then the last thing would be is we divide by the number of people. Okay, divide by the number of people. All right. So that would be how you break this down. And I'll let you go through and click this one here and figure out the rest of the steps. But that's basically how you break this down. I know it seems like a lot here, but you just have to take it piece by piece, right? Again, I'm trying to figure out the cost per person. So I need to know what the cost is on top, right? My cost will be on my top. And then it says per person. So again, when you say per, that's like putting a division sign. So this top part here would be the cost. That division sign is like saying per and then percent, right? The cost per person. You got to figure out the total cost on top divided by the number of people. All right. So for this one here, okay, the blank of a rational expression cannot equal 0, right? And the answer for that one is denominator, right? The bottom part cannot equal 0, because if it does, it's this thing called undefined. We cannot divide something by 0, all right? And when is the rational expression equal to 0? Only when the numerator is equal to 0, only when that top part equals 0, okay? And then again, when a rational expression is undefined, that's when the bottom or the denominator is equal to 0, okay? So again, that's why this answer here is the denominator cannot equal 0. All right. So again, more practice here, but what value of the rational expression when x is equal to 4? Okay, all you do is you plug in 4 for x here and then you solve, okay? And then one of these questions is gonna ask you, when is it undefined, right? You set the bottom equal to 0. It's gonna ask you, when is this expression equal to 0? You set the top equal to 0. Okay, so hopefully not anything too terribly difficult. All right, So again, what is the value here when x is equal to 3? So you just plug in. So we've got 4 divided by negative 1. Okay, we've got 4 divided by negative 1. So the answer should be negative 4. All right, again, all I did was 3 plus 1, 3 minus 1. 4 over negative 1. Okay, for what value of x is the rational expression equal to 0? So that would be where the top is equal to 0. Okay, so again, this is where terminology comes in. The top or the numerator is equal to 0. So you would set x plus 1 would be equal to 0. All right, so if x plus 1 is equal to 0, then x is equal to negative 1. All right. Where is it undefined, right? So undefined means that the bottom or the denominator is equal to 0. So x minus 4 is equal to 0. So it's undefined when x equals 4. It's undefined when x equals 4. All right. So again, looking at our study sheet here. Okay, a rational expression is again 2 polynomials expressed as a fraction. All right. And in order to look at this or to evaluate, right, to evaluate or to solve, you would sub in for a specific number. So if it says evaluate this fraction when, or this expression when x is equal to 2, all you do is you plug in for x as the value of 2. Okay, that would be to evaluate. When we are asked to figure out what is 0, you just set the numerator equal to 0, right? That top value is equal to 0, and then you solve. To make something undefined, the bottom or the denominator is equal to 0. Okay, the bottom or the denominator is equal to 0. And then if it's something that's not already factored out, okay, you might have to take an extra step and factor out the denominator or the numerator, right, depending on which one it's asking you for, okay? So if it was the bottom part here, you might have to factor the denominator. If you have the top and it's unfactored, right, you might have to factor the numerator. All right. Quickly going through the checkup so we can at least start the next section. All right. So again, just knowing what it's asking you here. What is the value of, find the value of the rational expression. Okay, so for all of these, you're just going to plug in the value of x. So you plug in 3 for x or negative 1 for x. For this one here, where the rational expression is undefined. Okay, undefined. Again, you're going to solve for the bottom. You're going to set the bottom equal to 0. Okay, set the bottom equal to 0 and then solve. And then for this one here, when the rational expression is equal to 0, all right, that's where you set the top equal to 0. You set the top equal to 0. All right, and number 9 here, number 9, if this wasn't already factored out, right? So if this was x squared plus something x plus your constant, right? You might have had to factor that guy. But since it was already factored, this should just be easy. You set x plus 4 equal to 0 and x minus 2 equal to 0. All right? So, again, there you go. You set both of those equal to 0 and you solve. You set the denominator equal to 0 and you solve. And then you just plug in values here. So hopefully not too terribly difficult for this unit. All right, so that's talking about rational expressions and how do we solve them, right? So now we'll at least get started on the introduction, and I can make the rest of the video, if necessary, for simplifying rational expressions. Okay, so all right, so all this is talking about is bringing it down to the simplest version, right? So denomination denotes. I don't even know how to pronounce that word, if I'm being honest with you. I've never seen it. Okay, because what we just say is less is more. So this diminution, it means less. Denotes means is. And this large A word means more, right? I think it's aggrandizement, actually. So that means more, right? Basically, what it's just saying is if we can simplify it down to something easier and more manageable, why wouldn't we do it, right? That's all it's saying here. So for this guy here, we're going to focus on how do we bring it down to its simplest form. How do we bring it down to its simplest form? Whether that's factoring, whether that's division, multiplication, whatever, right? So the way we can do this is finding this thing called the greatest common factor, right? So it's very similar to the greatest common denominator, but now we're looking for it as a factor since that's what we're dealing with, all right? So if we look at 15 over 18, right? It might have been a while, it's been a while maybe since you've thought about this, but we can actually bring 15 over 18 down to a simpler factor, all right? So what we could do with it is we could know that 15 is made up of 3 times 5. 18 is made up of 2 times 3 times 3, all right? So technically, the greatest common factor for 15 over 18 is 3. The greatest common factor is 3, all right? Again, because 3 is in both of those values, all right? So if we take out 3 from both of our values on the numerator and the denominator, we get 15 times by 3 is equal to 6 times by 3, right? And hopefully we know this by now, but if you have something on top and something on bottom and it's the same, you can cancel them out. So we're left with just 5 over 6. So 15 over 18, the simplest way that we can write it is 5 over 6. And what we did is we pulled out a 3 from the numerator and the denominator. All right. So then here, if we can remember, hopefully we can remember this principle, okay, that a squared minus b squared is equal to a minus b times by a plus b, right? So that was one of our principles there. So if we look at this, if we factor both of these guys, right? If we factor both of these guys, so x squared minus 1, all right, that's fitting this form here. So I've got x minus 1 times by x plus 1. If I simplify the bottom, I've got x times by x plus 1. So obviously the greatest common factor is x plus 1. All right. So if I rewrite these, pulling out my greatest common factor, what I can do is I can simplify. Apparently we have to do that on the next page here. All right. So my greatest common factor is this x plus 1. So what I'm going to do is I just cancel out the top and the bottom. I cancel out the top and the bottom. All right. And what you're going to notice here is it says where x doesn't equal -1 or 0. Where x doesn't equal -1 or 0. All right. And the reason that is because if I go back here, it said x where x doesn't equal -1 or 0. Right? And the reason that is because that's the two values that will make this expression undefined. Or another way of saying that is if x is equal to 0, my denominator is going to be 0. If x is equal to -1, my denominator is going to be -1. Therefore, that expression is undefined. So how we could write that is it's equal to x minus 1 over x, where x doesn't equal those two values that will give me that undefined. All right. Oh, perfect. Okay, so you may have noticed there's two values, okay, that make it undefined. So what we say is, again, exactly, x doesn't equal those two values, okay? Okay, so again, you have to consider the original expression when we're talking about things that will make the expression undefined, all right? So yes, technically when we simplify, we just have x value there, all right? But we also know that this came from a larger expression, so it also has to include the other values that could make it undefined. All right. We have to remember that. All right. Now, again, you have to be very, very cautious with this thing of common terms. Okay, so there's a difference between common terms and common factors. All right. So common factors are where they're multiplied together. Common terms are maybe just added together. All right. So for example, 5 plus 2 over 5 plus 3. All right. It's not, you cannot cancel out those 5s. It has to be multiplication. All right. It has to be multiplied together. So if this was 5 times 2 divided by 5 times 3, that would be fine. Okay. But it has to be a factor and not a term. All right. So again, Down here, I have x plus 2 and x plus x squared minus 1. Okay, I can't just cancel out these x's here. It has to be multiplication in order for us to cancel those out or divide. All right, so looking here, again, you can follow these kind of general steps to simplify a rational expression. Okay, so factor the numerator and denominator if necessary. Find the greatest common factor. Okay, divide it out from both of the numerator and denominator. Figure out which values can, which values the variables cannot equal, right? So what would make it undefined? All right, so for example here, if we have this really large expression, all right, x squared plus 2x minus x over x squared minus x minus 2, okay? So this one is obviously not in a simple form for us. So what we're gonna do is factor the numerator and the denominator, all right? And using what we already know all about factoring and all the stuff we did with polynomials last semester, okay? You should be able to find that it's x plus 4 multiplied by x minus 2 on top, and then x plus 1 and x minus 2 on bottom, all right? So then when we're looking, the next step is to find the greatest common factor. All right, and obviously the greatest common factor there is x minus 2. Okay, it's x minus 2. So what we'll do is we'll divide out the greatest common factor out of both of them. So we just kind of cancel them out or divide them out. So we're left with x plus 4 over x plus 1. All right, then the final step there is decide what values x cannot equal, or where would this expression, where this original expression be undefined, right? The denominator is equal to 0. So remember, we have to go back up to our original. So we would say x plus 1 cannot equal 0, and also x minus 2 cannot equal 0, even though we divided it out. All right, so when we write that, we would say x cannot equal -1 and x cannot equal 2, right? So again, how you saw that was x plus 4 over x plus 1, and then they would write where x does not equal -1 and x does not equal 2. All right. So looking at another example here. All right, x squared minus 121 over x plus 11. Okay, so you can factor the top. Okay, the greatest common factor is x plus 11. We divide them out and we are left with x minus 11. Okay, we're left with just x minus 11. But again, we still have to go back to the original expression to figure out what can x not equal. So x plus 11 cannot equal 0, so x cannot equal 11. So this full expression would say x minus 11, where x does not equal -11. All right. So again, simplifying this hopefully isn't anything too terribly difficult. It's just repeating the same process with a little bit extra steps or a little bit different logic here. Okay, so when you simplify rational expressions, you should look for common factors. Okay, again, common factors, things that are multiplied together, not terms, common factors. All right. Then here, how do you simplify a rational expression? Okay, we follow those 4 steps. Okay, factor the numerator and denominator if necessary, find the greatest common factor, divide it out from both the top and the bottom, and then decide which variables what values x cannot equal. Okay, what makes it undefined. All right, I will let you guys try some of those. And then looking here, simplifying this fraction. Okay, so if we were to look, the top 6 is equal to 2 times 3, right? 2 times 3. The bottom is equal to 2 times 5. Okay, so obviously we can cancel 2 out of both of them. So our answer will be 3 over 5. Okay, because we can divide 2 out from both of those. All right, looking at this here, okay, x plus 1 is on top and on bottom, so that is our greatest common factor. All right, so we're going to be left with 2 over x minus 4. So 2 over x minus 4. And look here, they already wrote it for you, where x is not equal to -1 or it's not equal to 4. So they already wrote that for you. Okay, so that would be my answer there. Same thing here, where x is not equal to -2. Perfect. okay? But what you have to do here first is we'd have to factor this top. So this is going to give us an x plus 2 and an x minus 2, all right? So x plus 2 and x minus 2, and obviously the bottom here is x plus 2, so we're just left with b, which is that x minus 2, okay? So again, hopefully not too terribly difficult here to start with. All right, if we take the last couple minutes here to just look at our study here, okay, so again, figuring out the steps. So simplifying a fraction, you factor the numerator and denominator, find the greatest common factor, and divide by that greatest common factor, all right? In order to do this for a rational expression, you do the exact same steps. You factor the numerator and denominator, find the greatest common factor, divide by both the numerator and denominator, all right? But we add a fourth step on here, and we just figure out where x cannot equal 0, right? What value is going to make that denominator 0? All right, so that's just our extra little step there with that guy. All right, looking at our checkup problems here, okay, looking at these checkup problems. Again, reducing the fraction, so just following those basic steps. Basically, figure out what the greatest common factor is and divide it out. All right. Reducing the rational expression. Again, they already did you a favor by writing x is not equal to those values, right? So they already wrote those out for you. So all you have to focus on is finding the greatest common factor and then dividing out and writing your answers, right? So again, just crossing out that, oh, they forgot to cross this one. All right, crossing out the factors that cancel, okay? And yes, I do actually write it out the way that they do. I would write out the full expression, and then I would cancel out what cancels and then rewrite my new expression there. All right. Okay, so that ends, actually we got through all of it, so there's no videos that you need to watch tonight for extra help, okay? So we got through unit 1, okay, we got through lesson 1, lesson 2, and lesson 3, or 1.1, 1.2, and 1.3. Okay, so for your homework tonight, you need to take those 3 quizzes, okay? Again, by all means, you are more than welcome to re-walk through Apex, do those extra problems, do those checkups before you go through and do those quizzes, okay? Because remember, technically for every 1.5 hours of class, you're supposed to have, around 1.5 hours of homework, okay? So by all means, again, go through, re-go through those and make sure that you understand what's going on, and then come tomorrow with those 3 quizzes done. So again, 1.1 through 1.3, all right? That's gonna be your only homework tonight, is to finish those units, all right? Any questions here? All right, make sure you are communicating with me if you have a doctor's appointment, if you have to miss, if you're whatever, right? If you've got questions, comments, or concerns. I know I got at least two emails from students during class. So if you were one of those, make sure you stay on and I'll chit chat with you. But again, communication is going to be key throughout this, and then making sure you keep up with the schedule is going to be really key for this, okay? So rather than trying to rush and do it all in week 4, right, try to keep up with us. So for tomorrow, if you want to be on schedule, you're going to get through those first 3 units and make sure you have those quizzes done, okay? Other than that, if you have a question, you can stay on. Everybody else, I will see you tomorrow. Juniors, I will see you at 10 o'clock. Goodbye, goodbye.